In this lesson, you will learn how to create a function to convert barcode data into a numerical value. Let's start with the program we saved from the previous lesson. Now that we understand the concept of Boolean numbers, we'll need to write the function in our program to perform the conversion. Above the detectLines function, add the following: int binaryConvert, open and close parentheses, and a set of curly braces. Now, let's build our code inside of the binaryConvert function. First, add a variable to store our calculated value. Type int binarySum equals 0, semicolon. Next, we need to create the algorithm to convert barcode segments into numerical data. Each segment represents a bit in our binary number algorithm. Every dark segment in the array will have a Boolean value of true, which is also equal to 1. Every light segment will have a Boolean value of false, which is also equal to 0. Remember that in the barcode, every segment has a numerical value, or multiplier, similar to a binary number. Segment number 1 has a multiplier value of 1. Segment number 2 has a multiplier value of 2. Segment number 3 has a multiplier value of 4. Segment number 4 has a multiplier value of 8. And segment number 5 has a multiplier value of 16. To find the final numerical value, our calculation needs to add the values of each dark segment of the barcode. Let's build the algorithm. Add the first line of the calculation, binarySum equals, parentheses, line marker, open square bracket, 0, close square bracket, asterisk, 1, close parentheses, semicolon. This calculation will multiply the values stored in the line marker array at index 0, which will have a value of either 1 or 0 by 1, and store the result in binarySum. This works because if the first segment was dark, 1 should be added to the numerical result, but if the first segment was light, 0 should be added. Multiplying any value by 1 results in the same value, while multiplying any value by 0 results in a 0. Next, add binarySum equals binarySum plus, open parentheses, line marker, open square bracket, 1, close square bracket, asterisk, 2, close parentheses, semicolon. Because the second segment, line marker array index 1, has a binary value of 2, we need to multiply its value by 2. Then, after multiplying, we add it to the previous value of binarySum before storing the new value back into binarySum. To save time, since the last 3 segments use a similar calculation, go ahead and copy this line and paste it 3 times below. After pasting the code, change the array indices for line marker to read 2, 3, and 4, and then change the multipliers to 4, 8, and 16. Great! The function will check the 5 segments, and if a segment was dark and marked as true in the line marker array, it will add the binary numbers multiple to the binarySum variable. If a segment was light and marked as false, it will multiply the binary numbers multiple by 0 and not add anything to the binarySum variable. The final piece to the function is the return command to report back the calculated value in binarySum. Add return binarySum semicolon. Our binaryConversion function is complete. All that's left to do is to call the function inside of the detectLines function. Add the 2 following lines of code. At the top of the program, right below the line marker array, add int barcode number semicolon to create a global variable to store the numerical value of the barcode. And at the bottom of the detectLines function, below the for loop, add barcode number equals binaryConvert, open and close parentheses, semicolon, to store the result of the binaryConvert function into the barcode number global variable. Save the updated program, and then download it to the robot. But keep your robot connected to the computer. Once downloaded, place the robot at the starting point of your barcode test bed, and press the Start button on the Program Debug window. The robot should move forward and stop with the color sensor over the first segment. Pause for a half a second and then repeat and check all 5 segments. Notice in the Global Variables window that the value of barcode number displays the result of the binary convert function. We've now successfully converted our barcode to a numerical value. In the next lesson, you will learn how to relate that numerical value to an alphabet letter in the letters array and display it on the LCD screen.